told you, David.
Just peachy. All right. So, where does all this come from, and how do we use this in real life? Hired. Okay. So this is an actual problem. This is real life right here. The city of Königsberg, okay, is in Prussia, which is now Russia. And it was set on both sides of the Fleury River and included 2 large islands which were connected to each other and the mainland by 7 bridges. The people of Königsberg wanted to know if it was possible to take a stroll through the city and cross each of the 7 bridges once and only once. Try on your own and find out. Okay, so instead of using a regular map, they decided to create a graph model. Okay, so they went here and they said each land is going to be a vertex. So you have your right bank, which is here, which has now become a vertex. You have this little island A in the middle here, which has become this vertex. You have this left bank over here, which has become this vertex. And you have this little piece of land here, D, that has become this vertex. Okay? Your edges then are the bridges that connect these two. So you have these 2 bridges right here, this bridge and this bridge that connect these 2 pieces. Well, that's these 2 lines. You have these 2 bridges right here that connect these 2 pieces, these 2 lines. You've got a bridge here, and a bridge here. So we've come up with this graph model. Is there a way to start at one of those dots, trace every line without crossing a line more than once?
You're gonna have to give us a set.
That's fine. Take a minute. Okay? I'm not telling you where you have to start. I'm not telling you where you have to stop. I just want you to only trace a line once and to make sure that you trace every line. Is it possible?
Do we have to end up back at A?
No.
Or like where we start?
No. I'm not saying you have to start at A and end at A. You can start at A and end at D. But again, I want you to trace each line once and only once. Can you do it?
It's not possible. Give it a sec. Not feasible. It is possible. Yes, it is.
Are you ordering a Dare to Stand Up shirt?
I already put my order in last week. Yes, ma'am. Thank you.
Thank you.
No. See, I got all of this.
Stop being so negative.
Stop being
It ain't possible. It just ain't possible. What you do?
Stop being so negative. All right, so I've got 2 people. Sienna, you said it's not possible, right?
Yeah, it's not possible.
Sienna and Dewan have discovered that it's not possible.
I also.
Whatever.
Okay? Peter says it's not possible.
It is possible.
Rodrigo still says it is.
You just
So
have
are
to
you
figure it out.
actually like you can just go like touch them, like go through?
All of them at once.
You can do that.
You can go to every spot, but can you trace every line without repeating a line?
Yes.
LDRA.
Dewan says there's always a line that is left out, no matter what we do. Okay, so let's look at a couple.
Oh, I just think I did it.
You think you just did it?
I think I just did it.
Okay, let's
Give it the answer. It's still not
So 1, 2, 3, 4, 5 left out.
It looked like a peach.
Yes, can you touch every line? 1, 2, 3, 4, 5. Okay, so right now we're looking at this ain't gonna happen.
It can. I swear to God, I did it, but I don't know.
Okay,
It's not possible. It is possible. Shut
It's
up.
not.
I'm gonna tell you right now, it is not possible.
Oh.
It is not possible. And today we're going to find out why.
All you gotta do is know why. It's not possible. It's not possible. Leave it alone.
But there's a reason why. There is a reason why. Okay, so we can draw pictures that represent a ton of different situations. So in this one, we can draw a picture that represents friendships. Okay, how many of you have watched Riverdale? That's what this is from. Moose is friends with Meg, Ginger, and Betty. Jughead is friends with Ginger and Betty. Archie is friends with Veronica, and Reggie is friends with Betty. Okay, these are all names from Riverdale.
I haven't seen season 3 though.
I haven't seen any of it. I watched like episode 1, and I keep falling asleep because I try to watch it too late at night, and I need to like spend a Saturday. But this Saturday I'm giving the SAT. Who's taking SAT with me?
What?
Yeah.
What's
Saturday morning.
Is what?
SAT.
Oh, I probably should sign up for that.
It's too late now.
I know, but I probably should have.
November 2nd is our next one.
No, I didn't take
That's
that.
when I take mine.
Do you need to take it to graduate? No, but a lot of colleges.
I'm going to
I'm not going to college. So anyway.
I don't know if you need it for DCCC or not.
All
right. So we can draw a picture of these friendships. So when I draw this, the edges are the friendships that they have, and each vertex is going to represent a person. So we start with good old Moose.
Moose was the gay one.
So Moose has 3 friends. So Moose should have an edge.
One of them was gay.
Okay. Nobody cares about their sexual orientation. That has nothing to do with what we're doing right now. Okay. So Moose is friends with Meg. So there's an edge that connects Moose's vertice to Meg's. He's also friends with Ginger. So he should have a vertex or a line or an edge that goes to the vertex that's Ginger. And he's also friends with Betty. Okay. So he should have an edge that represents his friendship with Betty. Okay, so we're good with Moose.
Awesome.
Who's Ginger?
We've got Jughead. Well, that's a new vertex. Jughead. Okay. Jughead is friends with Ginger, so there should be an edge that connects Jughead to Ginger. And he's friends with Betty, so there's an edge that connects him to Betty.
Is Jughead's birthday?
This is not accurate.
Listen, I've never seen Riverdale. Again, these are not my notes.
That's sad.
We'll just go on what you're doing.
Right.
So,
It is a good show.
Okay, so we've got Archie,
and Veronica.
and he's friends with Veronica.
Veronica's at Darky.
Okay, and then Reggie. We need a Reggie. Okay, and Reggie is friends with Betty. Okay, so you may have to, on your final, you might be given a situation and you might have to find the graph that matches it. Okay, so you're not necessarily going to have to graph this, but you might have to put a situation with a graph. So you need to know what it should look like. That's it. He teaches a not favorite. I keep saying I want to change stuff and I don't every year. One of these years. Possibly. Okay, so you should also be able to answer questions that go along with this. So if I say to you, who has the most friends?
Moose.
Not just Moose though.
Ginger.
Moose and Betty. If you take a look at this,
Oh, yeah.
Moose has a degree of 3, Betty has a degree of 3. So they have the same amount of friends.
Exactly. That's your mom.
Who has the least amount of friends?
Archie.
Archie, Veronica, Meg, Reggie. They only have one friend. He's way down at the bottom here.
Oh, yeah, right.
Okay? Poor Archie and Veronica, their only friends are each other.
They're not friends.
They're not friends?
They board friends.
Oh.
Yeah.
Oh, they girlfriend, boyfriend.
Yeah.
Oh, smoochy, smoochy. All right.
Smoochy, smoochy.
Questions? Okay? Just because I'm a huge hockey fan. Hockey's better than football.
What can I say both of? You got at least like one of them.
Listen, hockey's more fun because they get to throw the gloves on the ground and beat each other up.
No, I was a hockey game.
Maybe the
My birthday.
part.
I tell you what, they do the ass thing. That was lit.
Yeah.
Wow.
Sierra got us the bathroom.
Okay.
So.
You can represent games that have been played in a graph model. So we've got Pittsburgh
The Penguins.
plays DC.
You know, no, wait.
I mean, you don't need it.
I said the Penguins.
Okay, so Pittsburgh plays DC. We've got New York facing up against Philadelphia,
Liars. I didn't watch my
and Chicago and St. Louis. Okay, so we've just put Monday's games up. On Tuesday, Pittsburgh's going to play DC again. So what did I just create? A multiple edge. Okay, they've played each other twice. So each edge is a game. New York plays St. Louis.
Hold on. I gotta draw the St. Louis.
And Philly and Chicago.
So you have Philly and Chicago and New York saying, okay.
So where's the disconnect?
Pittsburgh is going to play St. Louis.
Oh, that's gonna be part of my graph.
New York is going to play DC. And Philly's going to play Chicago. Oh, there's another multiple edge.
Yeah, I don't.
Philly plays DC. This one's kind of screwed up. Pittsburgh and Chicago and St. Louis and New York.
I don't like my graph.
Woo!
Another multiple edge.
That one's kind of right. Another multiple edge. That one's kind of
I like my
I mean,
It looks great.
Oh, there you go. But it's not wrong.
Yeah.
I mean, it's sort of.
Okay.
They're playing hockey.
So
This is all.
they're playing hockey. That's right. Okay. Remember, in a hockey season, these teams play each other a lot. Okay. You don't just play one team once. So I should be able to give you this graph, and you should be able to tell me if I said how many games does St. Louis play.
Well, actually, 74.
St. Louis playing 1, 2, 3, 4.
Okay, St. Louis plays 4. Take a look at the degree at the St. Louis point. 1, 2, 3, 4. That's how many games St. Louis plays. If you actually look, I think each team on here plays 4.
Yeah, that makes sense.
Chicago has 4, New York has 4, Philly has 4, DC, and Pittsburgh. They do. The Carolina Hurricanes.
I swear it was a story in like one of our finals about that, like a long time ago. I think like 10
Possibly. Mhm. Yeah, we have a hockey team.
They got them.
Are they
One of
good?
these days, I will get to a North Carolina Pittsburgh hockey game.
Are they good though?
Yeah,
I don't know.
Yeah, they made the playoffs this year.
Did they?
Yeah.
Okay.
I'll be ESPN.
We can draw neighborhood watches as well as
Let's do
a
that.
mailman. Okay, so I can draw a map of a neighborhood where my vertices are my intersections. So, vertex, vertex.
Vertex.
Okay, so each one of my intersections is going to have a vertex.
Yours is draw that hard.
Okay, I'm actually going to move it over here. 2, 3, 4.
Right.
You're fine. You can put it on yours. I just need to move mine out.
I need mine
Two.
exactly like yours.
That's fine. We've got an intersection here and an intersection here.
I like it.
So each one of these dots represents where the roads cross.
2, 3, okay, see what else.
Yeah, that looks like braille.
We gotta go to work today, bro.
Okay, so
That shit every day.
we want the roads to be the edges in our picture. Okay, so you're watching the neighborhood. So you're that person that just walks around, and checks for weirdos.
There's a chick,
Okay.
there's 3 houses, like, little, and there's one that does that, like, can you please go away?
Hey, it's better to be safe than sorry. Okay, so as the neighborhood watch, you walk down the street, okay? You're just tracing the whole neighborhood, okay? You go up and down each block, and you're checking everything out, okay? You're left.
So the regular couple are real life?
You didn't connect that one.
What I missed? Oh, you're right.
Technically, you missed.
The real life
Oh,
thing.
yes, tab.
I missed that one.
There's one up there.
Oh, good call. I missed this one too.
Who lives right there? Nobody. Nobody lives right there. Nobody stay there.
This to move. There we go.
My block doesn't look like that.
Okay, so as the neighborhood watch, I can walk down the street and watch both sides at the same time. Okay. My second scenario is now I'm a mailman and I'm driving that little truck. Hey, they get paid good money.
They do.
Okay. Oh, they get paid some bank.
Just for delivery.
So we're not changing the fact that my intersections are my vertices. 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4. Okay, so I'm not changing the fact that my intersections are still my vertices. I'm not changing the fact that my edges are still my roads. But what is going to change now if I'm the mailman delivering mail?
You gotta stay on one side of the road.
You got to stay on your side of the road. So these edges aren't going to matter. The outside edges are not going to matter. What did I miss? I missed one over here. I knew I missed something.
I want you to start it. That one out there. And then
I'm not trying to do a starting point. Okay, so my outside edges are not going to matter. But when I go down the road where there's houses on this side and houses on this side, I have to go one way down the street and then turn around and go back the other way. So this is now a multiple edge. This is now a multiple edge. Multiple edge. Multiple edge. Hold on, I'm moving. Okay, so everything on the inside is now going to become a multiple edge. Because as a mailman, I can't zigzag as I go down the street. I mean, technically you could, I guess, if you want to get run over or arrested for driving down the wrong side of the road. Okay, but we're going to be legal citizens.
that's boring.
That's boring. Okay. So a mailman drives down one side of the street and delivers mail, and then he turns around and he goes back in the other direction. So that's what makes those multiple edges. So that's the difference between the watchman and a mailman. Okay, yes.
What is the loop? And just how much on
Ooh, got you there.
Why she gotta make this so
I know, but
like a cul-de-sac type thing?
Yeah.
I don't
that's
even
how
eat
I make it.
McDonald's.
You say you eat it, I'm gonna eat it.
You gonna eat it too big. And the people that make the food are nastier than the people that make it.
Now she's making me think.
Aha, see how it feels? Sucks down.
Would you like to see something you can't unsee?
I wanna see something. I
Oh.
wanna see something.
No.
That man David back there, he need to cut his hair or wear a hairnet or something.
I don't know.
Always.
Cause him up.
I don't know. You teach this person so you can't unsee it.
Oh, God.
They don't wear a hairnet. I mean, they should be
Oh, no.
people in the kitchen.
No.
They don't wear hairnets, they just wear a hat. Like, that's it.
Everybody else
Wear a
took
hairnet.
their photos standing, holding, standing with a foot on the ball. Not him.
Oh, my God.
Not him.
Okay. You're right, I can't unsee that.
You know the hell you don't.
Like, oh, it's literally what it was.
Arby's.
What you do, Miss Smith?
Some place they busy.
What happened? Say it, please.
You go to
Where did my
McDonald's,
thing go?
and
You
we're
are
not-
saying
Arby's.
I'm
not gonna tell you till you tell us.
I hit button?
You're not gonna, we can't tell you till you tell us.
Exactly. That's why you don't wanna work there, too many people be there.
Ooh.
It broke its head. Back up for a minute.
She said it broke.
It broke its head. There we go.
What you gonna do right here?
But I already get paid $7 an hour and I have to do as much work.
Oh, Hannah.
I'm still getting paid at the end of the day.
At the end of the day, you're right.
Same yet.
All right. So, just like the bridges of Königsberg, I want you to try what we call unicursal tracing. So, what I mean by that is I want you to take your pencil or pen or whatever the heck is in your hand, and I want you to start at this dot. Can you trace every line on here without picking up your pencil once and only once and make it back to that dot? Can you do it? Try the first one, the second one, and the third one.
It's possible. Miss Smith, this is actually possible.
This one's actually possible?
Yeah.
The one says I can do the first one.
Okay, so that-
Like that.
Dang.
Exactly.
My boy like that, though. I ain't slow. Just listen to that sentence you said, I ain't
No.
slow. Boy, yes, you is.
At least it's not big game.
Exactly.
Does she know how to do that?
I did it. I'm proud of myself.
No, we were talking about you being mean.
You
know how to
She's
know.
a bully.
I am bullied. I swear to God, I'm like the nicest person ever.
That's a lot.
Fred.
She lying.
That's why he's not coming to school.
Thomas, is this true?
Okay, you already.
You don't want to speak on it.
No, but this is about to be the last time.
The first one is. It's the second one. It's the first
Do
one.
the first one, bro.
I did.
Third was not possible.
You can't do the first one.
Oh, like.
Redo it. Wait, redo it.
Third
I
one's
forgot.
definitely not possible.
Is this a lot of tests?
I started right.
I'm gonna make it easier.
And then I'll-
Peter, I'm gonna make it easier.
I don't like it.
I can't do
I feel dumb right now. I don't like it.
I really should have made it easy.
You know it's not
Let's do
possible.
it a different way.
I don't like this. We never do this again.
Nobody like this.
Can we never do this again?
Yeah.
I like the little making the path thing. That's nice. Not this.
Man, no, I don't think that was possible.
Third and fourth. I mean.
All right, who wants to come up and do the first one?
Only the first one can go.
I'll do the
I
second.
do. First one, I'm still wanting.
I can't trace it.
it.
I'm gonna try it though. I try.
I don't want Derek.
I told
No,
you.
no, no.
Come on, Derek.
I was just motivated.
Derek.
There you go.
Start at the dot.
Oh, snap, tripping.
Right, that's why you messed up.
How you gonna put down?
See, there she go being rude again. Alright, boom, I'm gonna go this way.
Alright, alright.
I'm gonna keep on going.
Okay.
Alright.
Dang.
I'm gonna cook down.
Wow. That's just a little bit off. It's not his fault.
Yo,
It's cold.
Oh my god.
That's, oh my,
Oh my god, is this off? Did I not just adjust this?
you did.
Like,
but
how
you know
many
your
times?
you
board-
can tell
What you
us,
doing, Miss
what?
You know how your board is.
You need to do board. That's all.
Yeah, that ain't never
I'm
gonna.
gonna let this do that.
They can afford to get.
Alright, you just tell me which way to go, Derek.
I don't know though, I'm just talking.
Hey, you're the extra one that can get close to square one and all this stuff.
I do. I've done it a million times.
Okay, now
Alright.
look.
So you went this way
Boom.
and down, and then you were going here.
Yeah, go up, go up.
Go up
Cool.
and back down.
Yeah, go down. Oh. Oh yeah, go left, go left.
Go to the left, okay?
Go down, go over. Alright, go up left. Come down, go over. Okay, go up, go to the left, go back down,
Good.
over, down. Hold on.
Nah, homie.
See, you can't do it.
Hold on though. So I can go up, down.
Boom.
So I started. Okay, so Derek did it, but he started at one spot and he ended somewhere different. So this means that this isn't open.
Oh.
This is open. Okay, because I don't close off and I don't finish at that same spot.
Wait, so
No,
you
I
said
didn't
a
do
question.
that. I went the other way.
To the
I
small
ended it.
square too?
Yes, everything.
Yeah, that's not fun.
Okay.
Big talk's crazy. I did school runs. A little school run, y'all. Ooh.
She's obviously the smartest.
There's
Okay.
another way you can do it.
So she started and ended at the same spot. We consider this closed. Somebody want to come up and try this last one?
Nah, that's all on you. You got it.
That's on you.
That's on you, G.
It's your
That's
turn.
on you.
It's my turn?
Right.
All right.
Man, shoot.
Ah, you messed up.
Already messed up.
No,
What about that one?
no, she didn't.
Oh,
She
she
know what she
got it.
doing. She got it. She know what she doing.
You missing that top one?
I know.
She know what she doing.
I do know what I'm
Mind y'all
doing.
business.
Oh crap.
See, you know what she doing?
Damn, she don't know what she
Yeah,
doing.
that's what you're doing.
That's because this isn't possible. Okay, this one isn't either. There is no way to trace every line on that picture and either end. Okay, so they want to know, how does the terms path and circuit apply to open and closed?
Open path.
Path is an open and closed is a circuit.
Path is an open
And circles.
and a circuit is closed.
Somebody scratched my shoulder. Right up here. Scratch me.
Yeah, I'm born.
Okay? What other characteristics did we use when we did unicursal tracing?
What's the little?
What were we trying to accomplish? And we did in 1 and 2, but we didn't in number 3. To cover the whole entire thing. So our job was to trace every edge once.
I swear it be the most.
Okay. That was our job. Our job was to take our pencil, trace every edge once and only once, and either make it a path or a circuit. What did I do with my little one?
Most inspections, bro.
Yeah, they have one.
They have one every 2 months.
I think it's over
They
there.
have one every year.
It's usually right
Be like, y'all.
Or did I seriously put my little one
We
up?
just had one.
Nobody tell it, nobody tell it, nobody tell it.
Oh, it's right here.
Yeah,
Miss Beth.
Yeah, they probably share by the same people. Just different names.
Right
We
here.
had one there.
The other day. Last
Okay,
month,
so
oh, 2 months ago.
what you just did is called either an Euler path or an Euler circuit. Okay, so when we talked about paths and circuits before, we had to start and end at different spots for a path, but I didn't have to trace every line. So just a path is starting and stopping at two different spots. An Euler path is a path that travels through every edge of the graph. So this is open unicursal tracing.
Beautiful. I don't know how you say it.
Unicursal.
Cursor.
Unibrow.
That's a silly.
Okay. So again, the difference between an Euler path and a regular path is now not only do I start and stop at the different spot, I have to trace every edge once and only once. Once you have traced a line, you cannot go back over it. An Euler circuit then is going to be closed unicursal tracing. So your goal here is to go to every edge once and only once and make it back home.
I don't wanna go home.
Give me something.
So that's
Okay, there is a way to tell what you have and what you don't have. However,
No amount of lines.
I'm not going to tell you. You're going to figure it out on your own.
It's amount of lines. It's not
I
lines.
just draw.
Okay, so we're going to investigate. Okay, so we are going to investigate. So Sienna said the first one is going to be an Euler circuit.
Exactly.
I can start at A, trace every line, and make its way back to A. Okay, let's look at some characteristics of an Euler circuit. What is my degree at point A in this graph? 2. What is B? 2. What is C?
2.
And what is D?
2.
And how many edges are in this graph? 4.
Oh, yeah, four.
So if those numbers
First
are
C is
even,
8.
then it's
Right? Or am I speaking?
Okay. Take a look at number 2. Would you consider number 2
Oh, yeah,
a circuit, a path?
a path.
Okay, so a path. I can start at A and I end at C. So I started here and I ended here. So this is a path.
If we got a line, it's that.
Not necessarily. What's my degree of A?
3.
C is 3,
C is 3,
B is 2,
B is 2, D is 2, and how many edges do I have? 5. Okay,
Wait,
the edges, 1, 2, 3, 4, 5. Okay, good question. Okay, what do you think about number 3? Okay,
Circuit.
she said it's a circuit. 1, 2, 3, 4, 5, 6. I agree. This is a circuit.
It's even
I
wrong.
went from Drake to end up.
Okay, so I just counted 6 edges. A has a degree of 4. B is 4.
Shawty, I can't see.
C and D are both 2. You have the graph right on your face.
I went to copy it down from the board.
So you got one.
Okay, graph 4. It's a path. I start at A and I end at B. So A is 1, B is 3, 2, and 2. Yeah. B goes up to A, down to D, and down to C.
1, 3, 2, 2.
And 4 edges.
6.
Okay, I agree.
Hold up.
Graph 5 is also a path. This time we would start at F and end at C. 2, 2. C and F are both 3. D and E are 2. 1, 2, 3, 4, 5, 6, 7 edges.
Wait, hold on. I'm gonna make it. Oh, yeah, I see it. I'm asleep.
Okay, before you turn the page, let's talk about this. You already know.
Circuits.
Okay, take a look at all of my ones that you labeled a circuit, graph 1 and graph 3.
They're all even.
They're all even degree vertices. So,
I've got an odd though, even too.
So automatically, if I have a circuit, every degree in my graph has to be even.
Well, but number 4 ain't doing it.
But number 4 is a path. It's not a circuit.
You just said-
We're looking at circuits, just circuits right now. So graph 1 and graph 3. Those are the only two we determined was a circuit. Okay, so a circuit is graph 1 and graph 3.
Yep.
Graph 2, 4, and 5 are paths. They have even and odd. How many odd do I have? 2. The only way to have a path is to have exactly 2 odd vertices. Okay, so take a look at our path. In graph 2, I started at A and I ended at C. A is odd, C is odd. So when I'm tracing a path, I have to start at one odd and I end at the other. Same thing happens at graph 4. I started at A, it has a degree of 1. I ended at B, it has a degree of 3. In graph 5, I started at F with a degree of 3, and I ended at C with a degree at 3. Okay, so these are ways to figure out what your graphs are without actually having to trace them.
Wow.
Okay, so some things. An Euler circuit. What type of vertex do you start and end at? You can start and end at any vertex. But they must be the same. So that means I start at A and I would end at A. Okay. I can start at B as long as I end at B. I can start at C as long as I end at C. So I can start wherever I want as long as I end back in that same spot. Huh?
You got a Band-Aid this minute?
I do not. We decided that all of the vertices in these graphs are all even vertices. So I can simply look at a graph, find out all the degrees, and tell you it's a circuit, it's a path, or it's neither. I don't have to do anything else. Okay? An Euler path starts and ends at an odd vertex. And it also starts and ends at a different vertex. An odd vertex. And the start and end have to be a different vertex. So if you start at A, you would end at C. Or if you start at D, you would end at B. Okay, you cannot start and end at the same letter, and your start and ending spots must be odd. And the vertices in Euler paths are 2 odd and the rest even. So this means if you have 4 odd vertices, you don't have anything. If you have 6 odd vertices, you don't have anything. It's not a path, it's not a circuit, it's neither. A path has to have exactly 2 odd. Okay. You just came up with the 2 theorems that you were supposed to learn. If a graph has any odd vertices, then it cannot have a circuit. If I have any odd vertices at all, it's automatically not a circuit. A graph has to be connected and every vertex is even to have a circuit. It has to be connected and every vertex has to be even.
That's gonna be on the test, like, stuff like this.
So on your test, you're gonna have 4 graphs and you're gonna have to tell me if it's a path, a circuit, or neither.
Okay.
There is one question that's on the release test that's about this. So I'm assuming it's going to be on your final exam. On our test, it's gonna be 4. And 4 of them. Okay. So if a graph has more than 2 odd vertices, then it cannot have a path. So if it has more than 2 odd, it cannot have a path. Because a path has to be a connected graph with exactly 2 odd vertices. Okay. We have one more investigation, and then I'm going to show you what I need you to do for your homework. Yes, you have homework. So don't whine, 'cause it's going to happen.
Can I still turn them on and work from like 2 days ago?
Of course you can.
For 70, so
Better than a 0.
180.
70's passing.
Better than a 0.
Exactly.
Amen. Okay. So, just like we did in the first investigation, let's talk about the degrees of each vertex and how many edges are in my picture. So, graph 6. What is my degree of A,
2,
B,
2,
C,
3,
D,
3,
E,
2,
F,
2,
G, total edges? 8. Good. Okay. If I just gave you that graph and this is all you know about it, and I say, is this a circuit, a path, or neither? What would you tell me? This is a path. Okay. It has exactly 2 odds, so this would be a path. Woo! Graph 7's a little
I hope
Fun.
they ain't none like that on the test.
They
God,
got
I ain't
one,
going.
two,
A has
three,
5.
A has 5,
Oh, God, I ain't not going out.
1, 2, 3, 4, 5.
B has 5, C has
What's C?
5, D has
3.
3, E has 1, 2, 3, 4, 5, 6, 7, 8, 8, and F has 4.
How much?
Woo!
Path.
Let's count these. 1, 2, 3, 4,
It's like
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
I said 14. I would've got
Okay,
14.
this one is a neither. Why did Sienna say this one was neither?
Got too much going on.
It has 4 odd vertices. Remember, a path has to have exactly 2. And then finally, the last one. We've got 3, 3, 3, and 3. And a total of 1, 2, 3, 4, 5, 6 edges.
See, simple. Simple.
Okay. Can you find a pattern between this
You do a loop.
and this,
And that's how you tie your shoe.
or this and this, or this.
Oh, if you add on, if you add on cross,
God, you right though.
if you add
In
on.
some way, always
No,
looks
like-
like you
no.
can take
Like,
half the numbers
No,
and add on.
because that's
Or
four,
times on.
and that's not,
That's,
never mind.
Coincidence.
No,
that's a coincidence.
That's coincidence.
For the
Okay.
last two.
It is something with totaling though.
Add them all up, add them all up.
No.
Divided by the thing.
Divided by
Say that
five.
one more time. Add it up and divide by 2.
Two, man, you
Okay.
Divided by
That's
two.
3 plus 3 is 6, 9, 12. 12 divided by 2 is 6.
So that's all you gotta do. I know it was something like.
Add all these up, you get 30.
Wow.
30 divided by 2
It's
is 15. Add all these up, 16 divided by 2 is,
8. So that's gonna work for everyone.
okay? So
Wow.
that works for everyone. So your relationship is your number of edges equals your total degree divided by 2. Or I can write that as my total degree. Total degree should equal 2 times the number of edges. Okay, and this works every time.
Every time.
Okay, so my total edges are half of my total degrees. Or if I tell you you have 10 edges, you should be able to multiply that by 2 and tell me that my total degree is going to be 20. Every time. Okay, so that even worked if you go back to these ones. Graph 1, 2 plus 2 plus 2 plus 2 is 8, cut in half is 4. You had 10, cut in half is 5. 12, cut in half is 6. 8, cut in half is 4. 14, cut in half is 7. Okay, so it works every time. So you just discovered your last theorem of the chapter.
Oh, you get on my nerves. I just be wanting to
And this states that the sum of the degrees should equal twice the number of edges.
Bro, I got a key. I'm trying to hold it. But it's on the notes. It ain't working.
Probably because it's not a lot.
I like the last chapter better.
You like the last chapter better?
Yeah.
Right,
Yeah.
I like that better. It's easy.
Chapter 4?
It's just
Right.
numbers. It's just numbers. I do that and be doing this, connecting lines, crossing this, doing no. That ain't for me.
That ain't for me.
Well, I'm just going to tell you this right now. You're going to be dealing with this for chapter 6, 7, and 8.
What the hell?
She got mad.
So far.
5, 6, 7, and 8 are all like this.
It's just adding more on to it. Let me see what got added.
Wow.
Wow.
Right.
Okay, so a summary of everything we just talked about. If I have no odd vertices, you automatically have an Euler circuit. If there's no odd, it's automatically a circuit.
Half.
If it's too odd, it's automatically an Euler path.
See, I'm getting the hang of it.
We should have been found this out right here.
Okay? If I have 4, 6, or 8 odd vertices, it's a neither. And then it's absolutely impossible to have 1, 3, or 5 odd numbers.
Can we get a note card on this test?
Okay.
We should.
We should, bro, because this is a lot to remember.
So you said 1, 3, or 5, then it's impossible.
Right. You can never draw a graph that has an odd number of odd vertices.
People are picking our angle.
Okay. This brings me to the last 2 problems that I need to show you how to do your homework.
So then towards your friends.
Okay. Here it is. Okay, so I should be able to give you any graph. You should be able to tell me it has a path, it has a circuit, or it has neither. Once you've determined that, and it has a circuit or a path, you're going to give me that circuit or path. Okay?
Oh,
So-
Smith.
If I give you a graph, the first thing I want you to do is count your degree at each point. So, we're at 2. Here we're at
3.
4.
Oh, I ain't see it, my bad.
Okay? Here we're at 2. Let's go around the bottom here. So here we're at 4, 2, 4, 2, 4, and in the middle I'm at 4. So what does this automatically make this picture?
Circuit.
Path.
Leave,
Neither.
You got it.
Impossible.
It's not impossible.
I said everything.
How many odds do I have? I don't have any odds.
So it's circuit.
So it's a circuit.
I said that.
Well, you said that.
Okay, well, everybody else is over here screaming.
That was the
path,
first thing I
neither.
said.
This is automatically a circuit. So, a circuit says I can pick any dot to start at. So pick me a dot.
2.
the one in the middle.
The one directly in the middle?
Yeah.
Okay. Directly in the middle. I want to trace every line and get back to that point. So, which way do you want to go?
To the right.
To the right. So there's 1. So now I'm here. Where do you want to go?
Up.
Straight up or diagonal up?
Yeah.
Diagonal up. There's 2. Now I'm here.
Down.
Down, diagonal. Wait, never mind.
Go left.
Go left.
Right.
Keep going left.
I'm gonna mess it up.
Let's think of
I'm
that.
gonna mess it up.
Go right.
She can
Then
still go
back
down.
Go down.
She can still go down and then left.
Okay, so you want to go down. So we're back at the middle and then left. Okay. So now I'm here. Diagonal. 5. Now I'm here. Remember, I don't want to go back here until I've touched every other edge. So left, 6, 7, 8, to the right, 9, to the right, 10, 11, 12, 13, and back up, 14.
Wow.
Crazy, man. Crazy.
I've traced every line and I've gone back to my starting point. This is what you have to do on your test. There are 4 of these.
Wow.
4.
I'm done.
Okay. Let's take a look at this second one.
I ain't-
What's my degree up here?
That's 3, man.
3. Here we're at
2,
here 3,
3.
4, 4, 4, and 2.
Okay, you got some odds and you got 2 odds.
Okay, good. Caleb says this is a path.
Yeah.
I have exactly 2 odd. So when I have 2 odd, that means I need to start at an odd and I will end at an odd. Does not matter which one you start or end at. So which one do you want to start at?
All 3.
Top.
We got a trace on the there too.
Okay, so Sienna says I want to go to the right, so there's 1. Now where? Straight. 2,
Down.
3,
Do the triangle.
up to 4, okay? Down, there's 5. Up here, so there's 6. I have to go down, there's 7. Across is 8. Okay, back up to 4, there's 9. Across, there's 10. And down, there's 11.
You could have did that so easy.
It doesn't matter which way you trace it. As long as you have touched every line and gone from the start to the end.
Oh, God.
On God.
Oh, so we gotta write numbers like that?
Yes.
Oh,
So, Euler's theorems are great.
It's terrible.
Okay?
Oh, I don't like this. That's not great.
This is terrible.
Why you get 2 like this?
said we got 3 more chapters like that?
Uh-huh.
Yeah.
Okay, so an Euler theorem will tell you whether you have a circuit or a path. You can count how many vertices and tell me if you have a circuit or a path. But what it does not do is it does not find a specific Euler circuit or path. So that's your job. Your job is, once you use the theorem to tell me I have a circuit in graph 1 or a path in graph 2, to trace the lines and number them to show me the circuit or the path. Okay. You're looking at like loop,
Oh.
path, circuit, multiple edge type of an idea. Okay. So here's your homework for tonight.
We gotta do all of these.
You have 11 problems. Stop. You first need to tell me, just like we did, count them. Tell me, is it a circuit or is it a path? If it is a circuit or a path, you then need to number the edges and give me your circuit or path. If it's a circuit, they want you to start at vertex A, which means you have to end at vertex A. If it's a path, it says you can pick the odd vertex as a start. I don't care which odd vertex you start at, but you must start at one odd and end at the other. Okay? Of these 11 problems, only one of them is a neither. Everything else, it's not 11. Everything else is a circuit or a path. Okay? So, I will tell you it is on the back page, but it is not 11. Okay? So, one of the ones on the back page is a neither. Everything else is either a path or a circuit. Okay? Okay? So, I need you to do these just like we did these ones. Figure out your degrees at each vertex, determine if it's a circuit, a path, or neither, and then trace your edges. If it's a neither, once you say neither, you're done. Move on. You cannot find anything. Okay? You have the rest of the period to work on this. I realize it's 10 minutes. Tomorrow when you come in, we are going to review. And your test is on Wednesday. I do realize that it is club day. So when we come in on Wednesday, I need you in your seats, ready to go. Okay. Club day Wednesday. It's our first club day of the year.
Yeah, I just trying to do what a VA gave. He didn't know he gave it for a person. He signed up. He didn't even sign up for it. I just gave it to him. He's like persistent that he's not the leader.
Yeah, he's been gone for like 5 years.
Who?